exit that because I've caught that by mistake. Go back to there. Shift, you want to go another down one, right? Vertical line down. Click to there. F8 again, and reset M2.
Right.
So we can also do it here, and we'll say where are we? Come on, where are you? There. Right, so what you've got now is here, we'll go and 3, okay, we'll do there you go. We'll change these round.
Right.
Just naming convention, that's all.
Okay.
Right, there you go. Right, so we've got that. Because you've got this bit, you need to convert it.
Okay.
It has to be converted, because otherwise it won't stay there.
It won't do anything.
Yeah, it's unless you convert it, it doesn't update everything.
Okay.
There is another view. Where are we? I'm just going to try and remember back now. Instruction list, right? Instruction list down there. This tells you what you're doing. So to start off with, you load X0 and X1. So you think you've got X0, which is open, a switch,
yeah,
and X1. So long as the load there is the start, right? So you've got that will set M1 and set M2.
Okay.
So the line start there. If M1 is set, then we get an output of Y0.
Okay.
And for M2, we get an output of Y1. Then for X2, an ANI is, whereas that is AND, that is, an ANI is, I can't remember what it's called. It's a normally closed. It's a bit like a. It's the same. It's an AND inverse. Yeah. So it's an AND inverse. It's basically meaning it's not closed. It's normally closed. It's that one there, F6. So it's what they call a normally closed.
Okay.
So that would set M3. Also resets those two. Yeah, you get the output. And that's the end. So we can go back to here, view. Go back to the ladder. So that's what that is. So basically what you've got here is, so long as that switch is made and that switch is made, those two are both set.
Okay.
These flags, so it sets those two relays or sets those two flags.
Okay.
Let's put some comments in for you. Right, these
Please.
3 bits here allow you to put comments in.
Okay.
This will allow you to put a comment underneath. See, the actual statement, but not the statement, it's a comment there.
Yeah.
This is a statement which goes above the line, and this is a note that goes with it. So what we'll do is we'll put a statement in there. Statement. Okay. Put a statement in. And the star, it just means it's ignored by the actual program when it runs through. Yeah, you can then put another one in there. Is it Obinder? Which was it?
You mean my name?
Yes. Obinder, that's
yeah.
it. I thought.
So
I'm getting you confused with the Obinder and the one I said Obind or Obinder. One of my colleagues is called Gobind.
all right.
And it's that's where I thought I know there's an A after yours. Is there a D in it as well? So that's where the confusion came in.
No, it's,
Sorry.
I understand. No problem.
And I've misspelt it. Author. Okay. We'll put another one in there. Date. March 2016, just. Yeah, and what we'll do is, just to be on the safe side, we'll put another one in there. Just a blank one. There you go, blank line to start. So, again, you have to convert. Then we can put down here. Oh, exit that, don't want that, I want you now. Normally, open switch. See, this is how it comes up underneath, you see, so that's why I can do that. I know it looks daft, but when I go like that, you'll see how it comes up.
Okay.
So all I'm doing is I'm putting this down to show you what it is.
Okay, thank you
Right.
very much.
And that one there.
Yeah, that will help me in
is
my
a
comment.
Internal flag.
So, look at that. Yeah.
Tell you, dyslexic fingers today. So that's an internal flag. Yeah.
Yeah.
So, and you can see straight away it's matched up here.
Yeah, because that's
Yeah.
that
So
links to the other one.
Yeah. So and down here, see, internal flag. I will do this one. That's an output. Okay. So that's normally X0 is right. Okay. It's come down here. I'll change that then and just say input. Yeah. So that's an input. That's an input. Same with that one. That's an input. Yeah, so I'm just going to leave those like so. That's an input. That's an input. Yeah. You'll have to try and remember that because it won't allow me to put it.
Yeah.
Okay. Let's try to do here the note. Okay, it wants to go down. It wants to go here. Go with that one instead then. X0 and X1, how's that? Let me try doing that, will it allow it? And X1. Okay, let's do it there. Let me try that. Let's see if it copy. Right, that's better. Right, there you go. X0 and X1 below, as in on this line
Yeah.
here, normally closed, right? So I can take you, take you out of there now and delete. Right, so that there means the if I go up to here and I do that one, X0 and X1. In fact, I can do it this way. Exit. Allow me to do that one, are you?
Yeah.
Only going to allow me to do it the once. Fine. Let's do it this way. Right. Does that make sense to you?
Yeah.
That one means they're normally open.
Yeah.
Normally open, if you think, like you say, think of a switch. To activate it, you've got to operate the switch.
Okay.
When you operate the switch, that closes. You get the cross through there. That means it's closed.
Yeah.
Right? So it closes, you close that one. So you switch that one on, you switch that one on, that will operate.
Okay.
That operates, sets that, you get this output.
Yeah.
That one's also been set, so that one's set, you get that output. Right?
Yeah.
Now,
So
when
this is
one
closed.
made,
Okay.
now at the moment those two switches are open,
Oh yeah.
right?
Yeah.
So these two outputs are on. If you switch them off, those are still set. Right? They are still set because it's in one state or another.
Yeah.
Yeah, you have to tell it to reset.
Okay.
Right? So this happens here. So once those switches are switched off and this switch is operated,
Yeah.
then we set
M3.
this flag, and that flag sets off this output. But those two now being closed and this one being switched on, so those two have been switched off.
Yeah.
I'll get a PLC and I can show you a little bit better what I mean.
Oh, thank you.
There's all your X's, right, which relate to the switches. There's all your Y's, which is in this case relate to the LEDs.
Okay.
I'm not going to upload it at the moment, but what happens is here, right at the top, we have X0, X1. So we switch X0 on, we switch X1 on, and these two internal relays inside the PLC are set. So the flags are set. We get that output and that output. So we would have that one lit and that one lit.
Okay.
Now, if you switch those off, nothing would happen. They would stay lit.
Yeah.
Because these two flags are still set internally because it's in one state or another.
Yeah.
But now, if we leave them switched on, we follow the program down, we then switch X2 on, nothing's going to happen because these two at the
Have been
moment
turned off.
are in the closed state,
Okay.
right?
Yeah.
They're in the closed state, so they are. That's normally closed. That's normally closed. So when we switch them on, in that sense, they work in an inverse action.
Okay.
So when you operate the switch, it now opens. We have to think of it's what's known as the normally closed. Normally closed means what it does when you're not touching it.
Yeah.
It's in its dormant state. Normally closed.
Just like you sleep.
It's asleep, yeah. So when it's in sleep, it's normally closed.
Yeah.
Right. So that's normally closed like that. This one, it's normally open. Which means that to get it to operate, I have to Put the switch. Yeah. In this case, if I operate the switch, I open that. Right. So where that is at the moment, that is open. I've closed that one. Nothing will happen until I switch that one off and switch that one off. And then what you happen is now it allows the signal through, sets M3 and resets these two flags. So it resets the other two, so those now go off and that one comes on. Right? That's how it's set.
Okay.
Right? Don't know whether it will work. What's the Let's give it a go. See if we get anything. I might not. See if I get anything coming up on here. I need to know where you're going. Come for. Ah. Or are we? I'm hoping that's COM4 because it could be somebody else completely. You know, USB serial. Yeah, COM4. Okay, let's try and. We are powered up. I want to go to. Right, PLC. I'm going to change it to a 1S for a minute because that's the one that I'm using here.
Okay.
It's exactly the same. Right, if I now go to view, no, where are we? PLC diagnostics. No. Shut up. That's the one. Should come up on here. PLC type is not being seen. Okay. Okay. Yeah. All right. Will you please bloody well sorted out. Okay. Let's go back to here. Why is it got a 0? That's better. That's better, thank you. Okay. So all we've done is we basically changed it over to that, made sure that it's connected to the right COM port.
Okay.
It has to be in program mode, which is basically not in run.
Yeah.
And that switch inside there, you just push that up, puts it into run mode. That program is now in the memory here. So if you remember what we said was, see, nothing's happening. Right, so hang on, first of all let me switch the 24 volts on. That means that 24 volts is now applied to everything here.
Okay.
Right, that's not going to do anything, that's not going to do anything. You can see the lighting up on here, showing you've got an input on them.
Yeah.
They're not going to do anything because they're not connected to anything.
Yeah.
Right, so I switch X0 on, X0 is on, yeah, nothing. And I'll switch X1 on, right, so I've now done that one and that one. They're on, that's been set, those have been closed,
Okay.
right, that comes on, that comes on.
Yeah.
Now, if you remember what I said was, because they were normally open, we've closed them. But if the inverse of that is if it's classed as a normally open, normally closed, then it becomes open.
Yeah.
Right? That's normally open, we've closed it. If you give it another option, is to have it as a normally closed, that now becomes open. So the next part of this is X2. Right, X2 closes. Well, as you can see, these are still on. If I switch that one off for a second, I said to you, if I switch these off, these will remain on. Right, because those flags have been set
As it says.
internally, so now we need to reset them.
Okay.
Right, so long as that is there, it doesn't do anything.
Yeah.
But X2 comes on. So that's now closed, but at the moment this is open and this is open. So we now need to switch those off, right, to normally closed. And as I switch one off, you'll see the next action will happen, right? If I switch X0 off, nothing will happen. Or I switch this one off, nothing will happen until the other one does, because we're not completing that line.
Yeah.
So that's broken, that's broken. So I can switch that one first. Nothing will happen.
Yeah.
Now when I operate this one and switch this one off, this criteria will be made. So that one will get set. We'll set that flag, Y2 will come on, and also 1 and 2 will reset. And 1 and 2 are connected to outputs 0 and 1. So basically, when I switch that one off, that light should come on and those two should go off.
Mm-hmm. Alright.
Okay?
Yeah.
Does that help a little bit to be able to see it visually?
Not a little bit, much help. To be honest, like.
So there we go. And like that, nothing happens then, you see, so because that's how it's set.
Okay.
So, okay?
Yeah. Can I play around with it?
Cool, yeah, of course you can. You can play around with this as much as you want. If you need a hand to be able, your best thing is write it into here. Do what you want and play around with it as much as you want. But this is a ladder logic program now.
Yeah.
So this is actually what the PLC is going to do.
Yeah, and that's exactly what I want. Like, if it receives the wrong signal, if that one is turned off, that one should come on. That's exactly what I need on my project.
Okay.
So.
All right. But yeah, by all means, have a play with it, and it's easy enough. I'd say all this is just a unit that we've built around the PLC.
Yeah.
Just to enable a student to either, well, they have two choices. We have 24 volts that we can, so you can either have it, normal PLC will sit in a rack, have a load of wires connected to it on the inputs, a load of wires connected to it on the outputs, right? We can connect a wire to each of the inputs and one to each of the outputs. And you have a stack of ground, yeah?
Yeah.
So that's what you would give you your inputs and outputs.
Okay.
To be able to allow you to simulate that, we have 24 volts here, simulating an input. So it's now connected to the other side of this switch.
Okay.
Right, so it's switch up for the socket input, switch down for 24 volt input. So now I'm telling it, right, I'm going to tell you now that I've got that one, and it will start again, right? Because I've still got that. That one will still remain on. And that's it. So there we go. And we'll do that. And we'll do this bit here. That's M3 to there. M3, we'll put that on, and we'll have another one. We can add one more line in just here, and we'll do right click, insert line. There we go. And we'll go from you. We want a normally closed contact of X2, and that will do a reset M3. Okay, cancel that. Reset M3. Right. So basically what I'm saying is, here, convert you, convert, is so long as that is in that position, normally closed, it resets M3.
Yeah.
So its operation here allows us to set M3, and us switching it off again here resets it. So once you've done, you've converted, you need to, right, so any alterations you make, the first thing you need to do, you need to convert it, yeah. You then need to switch this off there. Doesn't matter about this bit, you need to switch it off and take it out of run.
Okay.
Yeah. If you try and do it with it in run, and you go to here, right to PLC, and you go there, and you go right to PLC, you only want the main part of the program. We don't need to send all these comments over.
Yeah.
Right? It's on COM4, we know it is. It's an FX1S, which is that model.
Yeah.
Yeah. So we execute, right to the PLC, and it will come back now telling there's an error, right? Stop remote, right? So it's basically telling me it can't because this is running.
Yeah.
Control the PLC stops. Yes, okay, fine. So, right. So it's basically stopped the PLC while it's doing it. But all we do, because it means that you can actually force the program to update.
Okay.
In the sense that you're, how you say, right? There we go. Let's try it. Right, it's basically you're saying you're the other side of the world.
Yeah.
You don't want to turn around and say to someone, just go out and switch that PLC to there, right? Because if that's the case, you may as well get him to upload everything at that point as well.
Yeah.
You're trying to do it from a distance, so it's going to be in the run mode. So you've got to execute, yes, and it comes up saying, after stop remotely, is the PLC writing executed? In other words, do you want me to stop it remotely?
So I will screenshot that.
Yeah.
Please hold.
Right.
Yeah.
It's basically, it's after you've got it, it's doing this, it's a case of, are you sure this is what you want to do? Because this PLC is running at the moment.
Yeah.
So do you really want me to stop the PLC whilst you upload a change to it? Well, yes, we do. So it's warning, the control of PLC stops, please execute after confirming safety. So
Yeah.
yes. Right? So then it checks it, so it's now writing the program to it.
Yeah.
Right? and then it comes back and just goes, fine, right, that's done. Yes, okay, we're happy now. Thank you very much. We're complete.
Okay.
Yeah?
Yeah.
So that's it. We can now close that. So now the new program's on there. Now we go 1, 2, the 2 LEDs come on. Of course, once it's done, you can actually take this cable out as well. You don't need it.
Okay.
You just leave it plugged in for the sake of it. Right? We switch those off. Sorry. With those switched off like that, that's still there. We switch this one on, that one comes on. And as I switch this off now, that should go off. There we go. So now you're back to the square one. All right?
Okay. Yeah.
Good.
Thank you very much, Martin.
No problem. It's very simple to do. Let me see if I can close that. You're not logged off, you're still logged.